This is a quick VLSM methodology review, primarily used for CIT 160 and 162. So let's get started. The important thing to realize is we're working with binary, and the worst part about variable length subnet mask is simply that we don't like binary. Our brain doesn't like going back and forth between binary. All right, so let's take a look. Binary system, it's simple to remember. We're used to the decimal system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Once we hit 10, we run out of numbers to use. These are the numbers we have. To go to 10, we need 2 spaces to do it, so we do 2 spaces. This is 2 characters, right? We continue on this way. We continue on this way until we get to 20, and then 30, and then 40, until we run out of characters for the first batch, and then we have to add another character and go to 100. All right. To us, this is completely normal, and binary works in the very much the same way. The only problem is we only have 2 numbers in binary. We have a 0 and we have a 1, off or on. That's the only way binary works. So the way it works is we got 1 equals, well, that's simple enough, 1, right? 0, sorry, I forgot 0, equals 0. We're fine, we're good. Once there's just 2 characters, it makes perfect sense. It matches up with decimal perfectly. But what happens is when we go to 2, well, with the binary system, we're out of numbers. So all we have to do is we have to, just like we do in decimal, add a space. In this case, it'd be 1, 0. Okay. 3, again, we have enough characters to do this. We just do 1, 1. 4, well, we're out of characters again, right, to make a unique identifier. So what we need to do is add a 3rd space, which would be 1, 0, 0. And what happens is every time we double it, or every time we go to a power of 2, we're going to need an extra space. So what we could do is use this up here, as I like to call a Rosetta Stone, to translate binary numbers over to decimal. So let me clear these notes and we'll get started. So if I just do real quick 0, 1, 1, 0, 0, 1, 0, 0, right? What that's going to equal is, well, I just put it underneath these. 0, 1, 1, 0, 0, 1, 0, 0. What's that equal? Well, I just add them up, right? So I take 4 plus 96, 64 plus 32 is 96, plus 4 is 100. All right? So in a nutshell, that's the binary world. Well, when we write an IP address down, 32 bits, 8 bits per octet, we write it down, and we separate those octets with periods. We write them down in decimal numbers, and we think we're being very clever. So let's just write down 10, 110 dot 30 dot 2, let's say. Well, if I wrote that out here, 10 would be 0, 1, 0, 8 bits on. That's it. 10, 10 is 10. 0, 0, 0. 0. All right. 110, well, 128 doesn't go into that. 64 does. That gives me 96. So 96 plus 16 would be entirely too much. So 96 plus 8 would give me 104. That'd give me 108. That'd give me 110. And I don't need a 1. 30. We go 0, 0, 0. We'll take that 16. We'll take that 8. That'll give us again 24. 28. Oops, I was thinking too much there. 28. 30. Don't need a 1. Also keep in mind the last bit is always going to make the number odd, right? So finally, 2, it'll be 0, 0, 0. 0, 0, 0, 1, 0. Now, what we use to tell, remember, a network, an IP4 address, any IP address is composed of both a host portion and a network portion. And what we use is the subnet mask to draw that line. Well, again, we think we're being clever by writing down our decimal numbers. So let's pick on 225, 255, excuse me, 255, 255. Let's make this interesting. We'll make this 224.0. All right, we're not going to do classful stuff because, well, this is a VLSM class, right? So we write 255, 255, 224. It makes perfect sense here. 255 means that's part of the network. That should be it. This is part of the network. Well, part of this is part of the network, and part of it is with the host. Okay, it's going to look weird, the fact that these decimal numbers seem to be almost randomly assigned of what's part of the network and the host. But when we get to the binary world, it makes perfect sense. These are all ones, right? 255, 255, 255, right? If I add all these up, I'm going to get 255. 1, 1, 1, 1, 1, 1, 1, 1, 1. 224, we're going to take the 128. We're going to add the 64, and we're going to get 192. Plus 32 is 224. All right, and the rest are all zeroed out. Now what that does, everything else has to be 0. This creates a border. Everything with a 1 is part of the network. Everything with a 0 is part of the host. And what that does, it creates a border wall. All right, and it says this is the network. This is the host. All right. Now, if I sit there and say, well, I got an IP of 10.110.33.1, is that on my network? Well, for us, we have to sit there and do some subnet calculations. For the computer, it's not a big deal. Because it's 33, it'd mean this bit would be turned on and that bit would be turned on. Well, look right here. This network ID is different from the network ID of mine. I have 30. I have all zeros in the network portion in the third octet. This has 001. It's different, and it's clearly different for the computer. But for us, we don't like it. Now, the good news is what this does for us is it designates what's called an increment, right? The networks, because of the way the rule works, the networks will increment by the number you have. So in this case, we have 3 bits that are hanging over, as you see with the subnet mask, right? 1, 2, 3. 3 bits hanging over in the third octet. The third octet being where the network host line is divided up. All right? Since it's 3 bits, you can go 1, 2, 3, 33. That's why I had 32. That's why I picked 33, because I knew 33 was more than 32. That was the network. We're in the 30 network. Okay, let me, so here we go. If we were to look at all the networks, the way this divided up the network was at every increment of 32 in this third octet, it's going to be a new network. So the first network would be 10.110.0.0 slash, CIDR rules. So all we do for the CIDR is we count how many bits we have here, right? So we got 8 bits, that gives us 16, plus 3 is 19, slash 19. That's our network, and that's the network we're on. How do I know we're on that? Well, because the next network, my increment is 32, is 110.32.0 slash 19. That would be the next network. My IP is 30, so I know I'm in here. If I go, if I go to 30, if the next network starts at 32 and I have a 30, I'm below that. I'm in that next network. I'm in the first network. So what are my range of IPs? That's the next question might be asked. Well, we'll take the 10, 110, right? Now the way we're doing this is we're going to just increment. Remember, so the only IPs that are not legitimate IPs are the network address and the host address, or in the broadcast address. The network address is going to have all zeros for the client portion, right? So I zero this out. By the way, if I zeroed all this out right here, that would give me 110. That would give me 10, 110, right? And then this would be all zeroed out, so 0, and this would be all zeroed out, 0, right? All you do is you zero out the whole host portion. Okay, and that gives you your network address. So the whole host portion is all zeros, so that's not allowed, and broadcast is not allowed. Well, here's the host one. So if I just click the very last bit on, this very, very, very last bit, right, that would be the first legitimate IP, .1. And we can count from there, 10.1, 10.0, .2, .3, .4, .5, .6. We'd keep going, all the way to the last IP. Now, the quick, easy way to do this, I could go IP by IP until I butt my head onto 32, or I could take that 32 and say, well, I'm just backing it up 2 IP addresses. And if I bet if 32 is the next network, 31 is going to be the border. As a matter of fact, 31.255 is the very next, the very IP before we get to 32.0, right? If we go sequentially. So, whoops. So 31.2, now 255 would be the very end of it, but that would be my broadcast, because if we do the math for 31, guess what? When I draw 31 out, you turn 16 on, you turn 8 on, you turn 4 on, you take 2 on, and take 1 on. That gives you 31. So all these are on. And then 255, all these would be on. They're all 1, so they'd be my broadcast. So I have to go back 1 more for my legitimate IP addresses. That'd be 254. All right, so everything between 10.110.0.1 to 10.110.31.254 are all legitimate IP addresses on this network that we have right here. The broadcast would be 255, 31, that's a 5. Memory's starting to kick out here. Doesn't like it when I draw too much stuff on here. 31.255, right? And the network would be this address right here, .0, .0. Okay? I got my CIDR based off how many bits are turned on. So if I'm given the subnet, 255, 255, 224, well, the way I get 224 is I take 128, I add 64, and I add 32. The first 3 bits are on, 8, 8, that gives me 16, plus 3 gives me 19. All right, let's do one more. And I'll do it as such. We'll just I won't mess with the binary anymore. Let's do it quicker. Let's do it fast. All right. I got my Rosetta Stone though. I need that. Let's take a Comcast address. We got 24.48.96. Since I'm recording this on the day that net neutrality dies, let's do a Comcast address here. 96.112. Let's do. All right, slash, let's put it in the last octet for giggles. 8 plus 8 plus 8 is 24, so we'll say this is 20/26. Okay, right away I know, because I have 2 hangers over, right? 8 are eaten up here, 8 are eaten up here, 8 are eaten up here. That gives me 24, and that means 2 are eaten up over here. Well, 6 bits are going to the host. Now, because of that, if you ask me how many networks I just made, what I do is I take the number of bits that hang over. I take the number of bits that hang over, and I put that to the power of 2. So my networks, the number of networks I've just created. You ask, well, how many networks did you make by doing this? Well, instead of just making this a /24 and using this last octet for host addresses only, how many network did you create? Well, I take 2. I take the number of bits I did to the 2nd power, and assuming IP subnet 0, I've done 4. I've created 4 networks. Well, how many hosts are those 4 networks going to have? Well, I created 4 networks with 6 bits in the host, so I take the 6. Now, in the case of the network, I only take it from the battleground. I only take it from the battleground. Okay, the battleground octet. I only take the bits from the battleground octet. For the hosts, I would take everything. So if the battleground octet was here and there was only 2 hangers over, I would still only take those 2 hangers over. And everything else, all those other bits would go to the host. Okay, so how many hosts? Well, with 6, 2 to the 6. Remember, I have to subtract 2, 1 for the network, 1 for the broadcast. So 2 to the 6 power gives me, and I can use the Rosetta Stone. I just have to start here, because 2 to the 1 power equals 2. So I start there. 2 to the 1 power is 2, 2 to the 2nd power is 4, 2 to the 3rd power is 8, 2 to the 4th power is 16, 2 to the 5th power is 32, 2 to the 6th power is 64, minus 2, I get 62 hosts each. All right. Therefore, I got 2 hangers over. My increment, my networks are going to increment by 64. That makes sense. I have 62 clients, right? So at 64, I'm going to keep clicking over to the next network, right? I got 0. That's my network. The first network there would be 24.48.96.0/26. Dot 1 would be my very first host. And it would go all the way to 62 for legitimate host addresses. At 63, that'd be my broadcast, and at 64 is my next network. So let's go by the networks to figure out where we're at. We got 0, we got 64. Well, we're pretty close, actually. I'm at 112. Let's see what the next one would be, 128. Aha, I'm somewhere in the middle here because I got 112. All right, since I have 112, I stop what I'm doing. I've gone over. Let's stop. I'm at 64. So my network would be 24, 48, 96.64/26. All right, my first IP would be 24. This is officially starting to slow down on me. 48. 96.65. My last, well, I'll just do a dash. My last IP would be, well, the next network's 128. Bracket up 1, that's my broadcast. Bracket up 2, that's my 126, which makes sense, right? Because how many hosts would that give me? Well, 62 hosts, including 65. That would give me 62 hosts, right? If I counted all the way from 65 to 126, I'd have room for 62 hosts, and that's what our math tells us how many hosts we can have. All right, and finally at broadcast, right? Our broadcast would be 24.48.96.127. Couple rule of thumbs that you can use to make sure you're correct in your assessments. Because the network, the last bit is always going to be turned off. It's going to always be an even number. The last octet's going to be an even number. Because the first address is always going to be turned on, it's always going to be an odd number. The last address, because the last bit's going to be turned off, it's always going to be an even number. And finally, the broadcast, because that last bit is always going to be turned on, it's always going to be an odd number. I hope this helps you study. Again, there's a number of resources online. Check the lectures. They have links to practice places where you can work on this, reverse engineer it, and also check for links to other YouTube videos that might provide a different perspective. All right, good night and good luck.